And hello student, my name is Shokshijal. In this session we learn the merge to 1D array in C language. So let us start. First I share my laptop screen and fix the position here so you can watch better my video lecture. And here Turbo C++, I double click and take some process, and now yes is open alt tab file menu taking file, and here our goal write a program to merge two one dimensional dynamic. Yes, so here use dynamic array in third 1D dynamic array. So that is our goal. So yes, here we can use malloc or calloc function. So that is a dynamic array, and we have to merge. So first we can scan two 1D one-dimensional array. So yes, I think you have to understand. So here we cannot shorting. Yes, in data structure, first we can sort and then merge operation is done. But here we just how to merge, that is we consider. So if you sorting, then ascending or descending. So first ascending and then merge to 1D array. So that is a, we can say that merge operation. That is also possibility. So here we can just how to merge perform operation in one dimensional array. So now I can first give one example. So let us our element I give as a first sorted array. So that is 1, 2, 3, and 5 only. First that is 1D array, and then we can let us check is a 6, 7, 8, 9, and let us 10. So that is a third array is a merging 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is a that our output. Yes, that is our output. So that is a first 1D array 1 to 5 and 6 to 9. That is a second 1D array, one dimensional array. So that is our goal. So let us now we can start to our coding. So stdio.h and then conio console input output dot h. So and then alloc. So malloc and calloc or free function. So yes, alloc dot h, and now void main. So that is it. And now what to do? So here we can first integer, that is a pointer x, then that is a, we can say that y, and then asterisk z. So that is our three 1D pointer variable, and then we can take yes I and j. So that is a complete, and yes we have to let us take as a k variable. So that is perfectly, and yes you can directly use that is a same only I variable, that is also a possibility. So yes that we can define yes only one index, that is also, let us check. So first I clear the screen. Yes, and then how many number of element. Yes, so we can take like first size, so n1, so n2, and then n3. So that is the size of 1D array. So first we can scan. Yes, and yes, so that enter 1D array size, and that is the first. Yes, here I write as a we can say that first 1D array. So yes, enter first 1D array size. So we can scan, and you can also send n variable, but here I give n1. So that perfectly. And now what to do? So first we can scan. Yes, here that we can print the message. So enter first 1D array elements. But before we can scan, we can allocation the memory. So malloc is malloc dot, that is the malloc function, and that we can n1, and multiply the size of integer. So that is a perfectly, and that is a malloc require the typecasting because that return data type is a void pointer. So in integer we have typecasting, and then can scan. So here we provide slash n and one for loop. So I that is equal to 0, I less than n 1, yes, and I plus plus. So we can scan, yes, first one D array. So first we can index, yes. So here we can say that x of percentage d and then I and scanf function. So that is perfectly. Here we can say that percentage d and ampersand x of I. So that scan. So yes, that is a we can first one D array scan, and yes, we can also print. Yes, so that is I just copy and paste. So that is we can say that not enter. We can say that 1D array element R, and then we can provide slash n. And here only one statement in for loop, so there is no required to pass, and that is percentage d and slash n, and that we can remove this press. So first only one. So that is a first 1D array we can scan with index and print with index. So yes, I first save. So that is we can say that one, yes, 1D and underscore merge mar p, but that is a only 3 character merge mer. So that's perfectly. And now yes, first 1D array. So let us check. I compile, no error. Let us check. So I give the like 5 and then 1, 2, 3, 4, and 5. So that is the first 1D array we can scan and print with index successfully. So step by step I can explain. So yes, here that is a size and we can provide as column, so that look better. And now I copy this all part, so we can as a second 1D array. Yes, here now first 1D array scan and print perfectly. Now we can turn to second, so I use as a y, and here that is a second. So we can say that and yes, that is second 1D array, and that size is we can scan n2, and here we can also use n2, and here I use as a calloc. So first we can use malloc, and here I use calloc, so only comma operator. And then what to do? So here we can also change, that is a second nd one dimensional array, and here and 2. So here we can use as a y, yes, I y, and here also y. So that perfectly. And then we can print, yes. So here also change the message second and one dimensional array element are and 2, and here we can also provide as a y, and here also provide as a y. So that is yes, here y perfectly. So save. So yes, now that is our second step. So I give like 5. So 1, 2, 3, 4, 5, and yes, enter. Yes, here we can provide slash n. So enter size. So I also give the and then 6, 7, 8, 9, and 10. So yes, you can look here 2 1D array, dynamic scan and print with index. So yes, here we can where we can provide, yes, enter one. So enter size here. So size time we can provide as a slash n here. And now we can merge operation take place. So here that is our input, and now we can start our output. So yes, that logic we have to start. So that is a for loop. And yes, first we can assign the size. Yes, that is the first process. So we can more and that not scan, but we can provide as a logic. So means enter third. Yes, here. So third 1D array size and 3. Yes, and that we can provide as a z variable, so perfectly. And here we can also use as a n3. So we cannot scan, but we can take like yes, here we can use only I index. Yes, so there is a no required to J and K. Yes, and also you can use N1, N2. That is just yes, only I. So let us only one index we can. So here what to do? So I assign to again 0, then I less than number of size. So we can yes here we can size scan, but yes that is a better. We cannot scan. Yes, enter 1D array size, but like n3 equal to n1 plus n2, so that is a by default we cannot enter yes directly. So first because that is a merge, so that number of size, so we can already scan n1 and 2, so directly sum and that allocation is done. Yes, that is better. And now what to do? So here n3 and then I plus plus, so it is a look for better. And what to do? So here we can first z of I, yes, and equal to that is a x of I, and then yes we can say that z of I plus, yes, here we can plus the index of our, that is a second 1D, first 1D array, so that is a perfectly. So directly that copy n1, so n1 size, and that we can assign to y of I. So I think you have to understand. So here what to do? So here z, that is a I is 0 and x is 0, but here that is a I plus n1, and that is a we can assign to our y variable, that is a I y of I. So both we can concat, means merge at the same time in one for loop. And now yes we have to print. So yes, here we can I just copy again this part and paste. So that is our logic, so that is output. So we can say that third, yes, here third third 1D array element R, yes, and that we can say that n3, and here we can print as a z. So it is a better. So let us check. I think we have to merge. So that is a merge operation. So at a one for loop, we can copy, means that is a just like copy operation. So first is a x copy, and then here also y same time copy, but that is a I plus n. So that is the first n size we have to count in I, and that we can in that is second 1D array we can store in the after of that index. So let us check that work or not. So yes, there is no any error. So I first give only three size, that is look better, means we understand. So like 1, 2, 3, yes, that print. And again I give the three second 1D array size. So we can say that 4, 5, and 6. And yes, here that is a first is copy, z is perfectly, but second that not perfectly. So that is a creating problem. So we can change the index. Yes, how that creating problem? So yes, let us check. Yes, here we can take as a watch window, so we can understand. So I first know what is problem, but we can take as a watch window. So alter w, and here that is a watch alter w and output. So let us we have to observe what is exactly process. So first is successfully merged, but second is creating problem. So what is a problem? So x of I, yes, and then y of I, and yes, that is, and then I only one index, so I just I, and then z of I, yes, and then z of I plus n1. So that is a perfectly, and then n1, then yes, n1, and n2, and then n3. So yes, you can also use only one, but that is a better. We can understand separate size of every one dimensional array. So now I can scan. So you can look, watch, start, and clear the screen. So I give yes 3. So yes, so that allocate memory and scan. So I give 1 again, that scan. I give 2. F7 I press 3. So first one DRS and then print. Yes, I just pass out. So you can look, that is a print in output window. Yes, perfectly. Now second one DRS size, again I provide 3, and then memory is allocate calloc function, and then we can enter, yes, scan. So I give the like 4, again 5, and again last 6. So yes, let us check. And now what to do? So yes, that is a print. Yes, 0, because I provide as a blank space, and 6. So that is the only we can consider as a 0 element, third, not 6, because blank space and I after give the 6. So that taking 0. So no problem. So let us check. Now what to do here? Yes, here that is a first x of I. So we can say that x of that is a not z, yes, that is a 0 index, and copy, and then y is a directly 4. Yes, that perfectly. I plus that is a 1. So here we can, that is, let us check. So that copy, and here that is a 4 element copy. So that perfectly, and here that is a 2. Yes, and then 5. So perfectly. And again I plus plus. So here you can look, that is a, and that I plus plus. So that index is, so here yes 2 and then 5. So and 3 and 0. So yes, let us check. And now what to do? So here and 3, yes, that is a creating problem. Yes, only 3 time loop is repeat, but and 3 we can merge all size, because only 3 time loop is repeat, so all element is copy. So here we can use any one index. Yes, that is a creating problem. So 3 plus 3 is 6, but here require only 3 times that our loop is repetition. So yes, that is a problem. So yes, here we can use any one, but that is a which one, that is the main problem. So here we can use any one index. So that is a better, we can use only one. Yes, here I repeat, there are give the t size, so I now give only n. So here you can scan n, and also I change the all, only one we can take as a size, so n, that look better. And here also n, same variable we can scan. So that is a perfectly. So and then here we can scan again n, same variable, and provide the memory allocation, that is a look better. And here and I remove, so we can remove the variable ij and 3 integer pointer variable. And then here and yes, that perfectly. And here there is no required to this merging, so directly we can provide as a how many size. Yes, that is a creating problem. So what to do? So yes, here require the memory allocation is more, so that we can provide. Yes, that is a creating problem. So how many size we have to take? So that is a perfectly. So yes, here we can use, that is any one of n that size, but here we can provide the memory allocation, that is a uh, n multiply 2, that type of we can exactly user, both is 3, that not possibility. So that is a creating problem. So what to do? So yes, that is a very, so we can assumption if user enter same size. So here we multiply 2. Yes, and then number of size is allocation. So n multiply 2. And then here is a only n. Yes, because that is a only 3 time loop is repeat, and that our goal is fixed. So let us check. I compile, and yes, one, that is n1. Yes, here is the only n, no n1. So all is only one variable, so no any error. Let us check. So I give 3 size, 3, and again I give the 3 size and 4, 5, 6, and look. So here that is a third 1D array. Yes, that repeat only means print only one first 1D array. Now second, so here again we can provide n multiply 2. So that number of loop is repeat. So that is now perfect. So again I give 3, 1, 2, 3. Yes, and here size is 3. So 4, 5, 6. You can look now that perfectly. So yes, that type of we can assumption. So both array 1D array same number of element if user is scan. Otherwise, I previously take the separate size. So you can take that one is a better. So we can assumption, but if user enter the different size, so here we can take as a n1 and 2 that previously is a better. So that number of memory allocation is required. And in this for loop in the merging, so we can take n1 or n2 anyone because only 3 times or any number of that loop is repeat. So that number of element is copy. So yes, I think you have to understand. Or other one important, if you not take like here, I again give like n1 and in n2, we can assumption user give the like first one here as a 3 size and second one here as a 5 size. So what happened? So yes, now we can again consider as a n1 here and n1. So n2 here, that is a no n1, yes, and now here n2, so second, and here also provide the memory allocation. So let us check, and only two variables, so n1 and n2, and then that is a yes, here is a 2, and now what to do? So here we can yes n1 plus n2, that number of memory is allocation, and that is a we can provide the loop is only one n1 or either n2. So that is a better. So which loop we have to repeat? So yes, n1. So that is a any one, and here we can same thing. So n1 plus not multiply n2. So yes, that is also better. Let's check. So yes, one n1. Yes, here is n1. Now perfectly, yes, here, yes, now here also we can provide as a size of 1, yes, n1. So first, yes, let us check. So I give first 3, yes, let us 1, 3. Again, I provide the 3 and 4, 5, 6. So you can look, that is also work. But when user enter the different both size, so that taking creating problem. So because here we can take directly n1 and 2, that is a perfectly, but here that copy is creating problem. So let us check now what happened. So now I first give the like uh, 5 size. So 1, 2, 3, 4, 5, and now I give the 3 size of second one here. So like 6, 7, 8. Yes. So you can look that is a perfectly, but sometimes that is a here there is no any error. But here you can look here we can first and that is our loop is perfectly work. Uh, but when user enter the both is here that is a first 1D array copy perfectly and second 1D array we can only take as a 3 element, so there is no. But in reverse case means user enter first is 3 and 5, so that time creating difference means some garbage value is there, so we can better that is user enter the same number of size that we can assumption, or first 1D array is a different and second is different, but in reverse case is some difficulty, so is a be careful. So what is the solution? So you can take to enter user same number of element size, that is only one way, or first 1D array different and second different, but in reverse order, like here I give the first 5 and 3, but first 3 and 5, so that is a creating problem. So now I can understand, yes, here we can discuss deep level discussion in what is a merge operation. So that is a merge operation. And now here that is our perfectly output is print. And now yes, here one is remaining, that is a free. So all that is a malloc and calloc. So we can X, yes, I copy and paste. So we can free, yes. So otherwise that memory is blocked. So X, Y, and Z, all memory is a release. And now we can last time, so 3. So 1, 2, 3, I give the sequence number of element, and then again 3. So like 4, 5, 6, because merging is required the ascending or that is order. So that merge operation is done. So we can assumption that we can user enter the shorted 1D array. Otherwise, you can apply the ascending, descending, that sorting first and then take merge operation. So yes, now I hope you can understand and enjoy this session. What is a merge operation in 1D array? In data structure, that is a very important, that is a merge short, that is a quick short merge, so many selection, insertion, bubble, so radix, heap, sorting techniques and searching. So that time I data structure take. So be wait, I also cover in data structure all these searching and sorting technique that known as a sorting technique. So now I can close this file. Yes, write this program to your C notebook. Very important. And what is a creating problem if garbage element if possibility. So we can discuss of this and we can take watch window. So any regarding in this definition. So in question in your mind. So you write in comment section. I give the definitely to answer you. Yes, and now close F3 and watch an output window and quit. So subscribe my channel Ashok Sinhalakini, press the bell icon to never miss any update. And thanks for your watching, supporting, and sharing my video lecture. And Hare Krishna.